So guys, welcome to a new lesson about Embergen introduction. Last time we talked about the software in general, we talked about how it works, we saw something about the simulation and the user interface, so we know something more about this powerful GPU solver. Today we start to focus on the emission and we are going to talk about the shape, so shape emission. So we are not going to focus on the dynamics, but just on the shape. So which kind of objects we can use to emit fuel and generate smoke, particles, flames, and stuff like that. So that's the emitter. You see that we have a connection with the shape primitive. We have the possibility to connect one or more emitter inside the simulation. So we'll see how to do it, which kind of possibilities we have. Let's go inside the emitter and say that we like to see the emitter. So you set to on the show emitter. Then we go to select the shape primitive. That's our first emitter. It is set to a primitive, so just a basic mesh. And we have more of one, so we have different possibilities to control the emission. And here you see a list of primitives we can use. For example, sphere. Each kind of mesh has its own parameters and properties, okay? So the simulation is reacting in real time to the emission change. We have the box, we have rounding box, so it's essentially a box with a round corner. We have the capsule. The capsule is partially down the ground, so we can move it. And again, everything is moving in real time. Then we have the Torus. And the Torus, we used this before. We have the cylinder. So essentially remember that we can manipulate the translation without any problem. So you see that we have the rounded cylinder. We have the tube, and the tube has the cap actually. So we can move the cap, remove the cap. So remove the first cap and also, if we need it, also the second one, by the way. Okay, we can remove it. And now we have both cap set to off. We have the cone, another shape, but it is working in the same way as the previous one. So you see we have different properties to control the shaping. Is really, I think it's really simple to understand. You see, and everything is working in real time. Again, the rounded version and then the ellipsoid. Okay, it's interesting because we are talking about basic primitives, but they are really useful to create complex emission. Let's see what happens if we have another shape. We are connecting both to the emitter, so we have two meshes. This one is out of the bounds, the volume, so if we set to on the show bounds. Okay, now you see that we have the mesh outside. We can move it inside, and then we have both sphere working as emitter. The dynamic properties and the fuel properties and smoke properties are all the same because the emitter is just one. We have two different shapes connected to the emission, so we are not changing how the emitter is behaving. So we can change the shape. For example, you see, it's not a problem. We have the previous one and the new one, and we can create another one. Okay, we connect both, and you see I can move it, and we have three different shapes emitting the same fuel and the same information as the previous one. That's interesting, but if we like to change something, for example, we like that the sphere, the big sphere, will emit something different, we have to create another emitter. So that's a different way. We connect both to the emitters inside the simulation. Now we are using a copy, so we go to select the new shape and connect to the second emitter, remove the connection from the first one. Now we can go to change how the second emitter is playing. So we can decide, for example, that we like to have just smoke, okay, and the other will work with fire. So select the emitter, Then we go to change something, for example, the fuel rate. So we have no fuel inside, so we have just smoke. The nice thing is that now we have two different emissions with three shapes, and everything that is working with the emitter is inside one simulation. It means that, for example, if we have the smoke velocity from the second emitter will be mixed with the other emitter, so it is just one simulation. So we are not talking about two different things. They are living and behaving together, you know, inside the solver, and the solver will take care about how the data will be mixed and how the data will be transferred inside the voxel space. And that's a really powerful way. So you have the possibility to have more emitters with different fuel and dynamic properties, and you can have different shape for each emitter. So it's a really powerful way. By the way, let's go back to have just one. Let's move again this one in the middle. Okay, and now let's go to see the other possibility we have. So we had properties, now we have mesh. Mesh is really powerful because it gives us the possibility to load stuff from outside Embergen. So you see that we have open mesh file, and then we have two different possibilities now, OBJ for static mesh and FBX. FBX can be used for static mesh or animated mesh. They are still working on the FBX, so step by step we'll have more and more feature. And they are working on the Alembic too, so we'll have a lot of stuff and a lot of possibility with animated emitters, animated collision, and it will be really amazing what we can do with it. So let's get in 3ds Max, a really well-known 3D software. By the way, you can do the same with Maya and other software, it's not a problem. So I'm going to create a Teapot, that's a primitive in 3ds Max. Then we can export this mesh in OBJ because it's static, so it's the simplest way to do it. So let's go to choose OBJ. We go in the folder where I'm exporting the curves. So we have the free tutorial, sorry, but I have a lot of stuff there, so sometimes it's complex to find where I have to put stuff. Okay, so Teapot, and it's nice to pick the preset for Maya, so we are sure that it's really well compatible with other software. Okay, let's close 3ds Max, and then we'll be back inside Embergen. So connect the mesh shape to the emitter. Then we get to remove this one. You see that we have no more simulation, and that's obviously clear. We have to load the mesh we created, but again, we have no emission. And that's because the mesh is essentially a polygon mesh. We need to voxelize because it needs to be generated inside the voxel space, okay? It is an internal conversion. Now it is visible, and it is working as the previous primitives we had before. Perfectly working, and it has obviously translation over the position and rotation, so you can manipulate this one as the other object. We have the forces as before. Everything is working as before, nothing changes. It's just like the other shape we used before, but this time we are using a file from outside. Then we have, for example, the noise. Noise is amazing. Noise is creating a noise 3D texture inside the voxel. So you see we have fire emitted by a noise map. So where we have the fuel, so where we have flames, it means that the noise is white, and the noise texture, I mean. And where we have no fire, the texture is black. So it works in the same way as you work with a noise texture, for example, for other kind of stuff like lighting and shading in other 3D software. We have position and we have rotation of the map, we have the scaling, so you know we are changing the noise texture and it is behaving in a really nice way, and everything again is working in real time. This one is really amazing because it can be used, for example, to create a cloudscape, and we'll see how to do something like that. You see that at the beginning, if we launch, we have some areas where we have the fire. So we'll take care about the cloudscape using the noise emission, and we'll work to decide where we like to have the noise emission in which area. So that's the scaling. You see, we can create bigger areas with emission and no emission. We have the octaves to have more details in the noise, and then we have other things like the lacunarity, the gain, and the amplitude. So you can just play with it because it's working essentially like the noise texture. You can make a lot of experiment with it to find the best look you are trying to achieve. Another thing that is really useful is the animation speed, because you can animate the evolution, the noise evolution. So you see that it's animated. The area where we have the fuel are changing step by step. So we can have a faster animation or slower animation, but it is working in an amazing way. Okay, that's really powerful. Okay, again with the scaling now it's more visible. We see that we have a lot of areas where we have fire and then we have no more fire, so it's really nice and powerful. Let's set, for example, to off, because we can decide if one shape is used or not used. It's really simple. Okay, let's go to see the others, the particles. Particles are really nice because it can play with some pieces of stuff that are launched away. So it's usable, for example, to simulate debris during an explosion. Let's see what happens. Okay, you see we have some stuff that are flying away and then falling down. So it can be useful to simulate trails, debris, explosion, and it's interesting and simple enough to be used. We have, as always, the position, the rotation, and the scaling. So we can move up, we can scale the emitter. So you see it's really, again, really simple to be used, but we have a lot of more parameters this time. By the way, it's better to have an higher quality, so we go lower with a voxel size. So in this way, we'll be able to see a better simulation. We see more details, but we have to scale up also the bounce, and I like to go a little bit down with the voxel size to have something better. So let's go for -6 on both, and 6 on both for X and Y, and -12 and 12 for the Z. Apply, and it's going to use a lot of GPU memory, so I think I'm losing a little bit of control over the user interface. It's not a fault by Embergen, but it is a problem with my GPU. It is an RTX 2070, so I have just 8 gigabytes, so I'm going real soon to change the GPU. Okay, now it's back, it is working back, and I have the right resolution. I hope to have a 3090 soon, but it is difficult to find something over the market. So it's better, we have a really nice resolution at this distance, and we have the stuff that are flying away and then falling down with the gravity. Okay, so let's start using both together. This one is really big, so maybe let's stop. Let's go with the teapot, and this one can be removed for the moment. Okay, so we have the fire in the teapot, and then we have the stuff flying away. The nice thing is that the speed, the velocity of the particles flying away are obviously changing dynamically. Also the fluid that is emitted by the teapot. Okay, so they are working together. We have different spawn type, for example, single burst, so we have just a burst, we have a multi-burst. Let's go back to see how it is working. So you see we have a burst, and then we have again a burst, so it's playing continuously. So we have a continuous emission of particles. And then we have continuous, that is another way to control the emission. So you can think about it. And actually, you know, we'll take care about it during the projects we are going to create really soon. But you can make some tests with both to find the best solution for your animation. Okay, so again, I like to say that this simulation is really simple. We are doing really nothing special, but you see that's really nice what we have over the viewport. So you see we have a lot of parameters. We have the fuel sides. We have, let's go back to the single first. Let's remove this one to see something just about the particles. Okay, that's the particles. Let's say that we are going to see some parameters for the particles because it's an interesting case. You see, for example, there we have the stretching. So it is going to emit particles, capsule particles. So we can decide, for example, you see the stretch. Okay. So it's in some way a possibility to control out the scaling. And then we have, for example, the speed. So we have a velocity range. So we have particles that are emitted using a specific velocity range. So we have, for example, -3, maximum 3 over the x-axis, and the same for the y-axis. So in this way we have some debris flying away faster and something slower. So something is growing up, something is falling down faster. So, you know, in this way, for example, we have an higher speed. So we are going to launch stuff over the z-axis with an higher velocity. And let's find another compromise between the minimum and the maximum. Okay, you see, that's really simple to control also how the debris are moving. So then you see we have, for example, the possibility to use extreme speed, but maybe if there is any case, we are going to use it later. We have the speed scale. This is essentially a scaling value, so it's a multiplier. Okay, so it's a different way to use it. We have the minimum and the maximum size. In this way, you are going to control the scaling of the debris, so you can have bigger and smaller debris, and that's really nice because if you have more variation and more chaos, it will be great for the simulation. You see, in this way we are, for example, simulating some big pieces and some really small debris. Let's go a little bit lower, and then the same for the life. So some will have less life and some other will be alive for more frames. So it's something interesting again to give a more chaotic look. Let's go back and play again. Okay, so you see we have some kind of variation. So, you know, it depends on the stuff you are trying to simulate and achieve, but it's nice enough. We have other parameters, you know, there. For example, the dragging, actually it's the same, the minimum and the maximum. So we have same dragging for all particles, but we can create also different dragging there. For example, 5 and 15. It's not so simple to see the differences, so you have to make some tests with more higher differences between the minimum and the maximum, but it will work. It gives you the possibility to have more dragging with the air. Then we have the shrinking. So, you know, the particles are scaling down during the life. So you can decide the minimum and the maximum shrinking for each particles. Here you have the possibility to do it, and again it gives us the possibility to have a more interesting look because we'll have more details. And let's see, for example, there we have the force injection. So actually the particle speed is giving 100% force to the simulation. You can decide to have more or less, and in this way you will have less speed, less velocity used for the simulation. So it depends on the effects you like to achieve, but you have also this kind of control, and that's really nice. And the interesting thing is that you can, for example, change how it behaves. Maybe it's not so visible actually with just the particles, but for example, it can be a little bit more visible when you have also the entire simulation. Okay, so if I have back the shape activity for our teapot, we should see, you see that the smoke and the fire that is emitted by the teapot is distorted by and moved by the velocity of the particles. Okay, so that's really nice. We can see the velocity, and you see that vectors created by the particles flying away, it's giving a lot of energy. It's visible because you see that the vectors are longer. Okay, you see there. Really nice. Okay, back to the simulation. Let's set to off again the teapot, just to have a better possibility to control how it is working here. Then we have the gravity. Obviously, it is the force that is making falling down the particles. So if it is higher, obviously we have particles falling down faster, but it depends also about the velocity, the speed we have with the particles. So you have to find the best compromise between both dynamic properties. So other things, there we have also some more dynamic possibility about the particle translation. We have the minimum rotation and the maximum rotation speed. Actually, everything is set to 0, so the particles are not rotating. We go with fire. Obviously, that's really low because it's 5 degrees by seconds. So we see nothing essentially, okay, because it's really slow. So let's go, for example, for 360 degrees over each axis. So the particles are rotating over each axis, and that's useful. Maybe it's too much. Maybe too much. Because they are rotating really fast and really so much. By the way, let's go back. Let's select this one, show. Okay, and let's see back how it is looking. So it can be similar to an explosion. You see that also the rotation is changing how the teapot emission is behaving. Okay, so that's really nice. Back to the emitter, we have the modifier. Modifier is able to give, for example, a little bit of control over the smoothing and the thickness of the emitter. It's less useful for the moment. We will talk about it later, maybe in another lesson when we need to use it. What I like to show you is the blend. So it's the possibility to blend different shape together. So let's go to use another primitive. This one is essentially a sphere. That's okay. Let's say that we like to show the emitter, and back with the reset. Okay, let's go to use a blend. You see that we have an input shape A and shape B. Then we go to connect. Let's go to change a little bit the parameters. By the way, we will change it later. And then the shape. Sorry, let's remove this one. So we have this shape connected there. Okay. What happened? If we go down, you see that actually we have something that seems strange because we have just an union. But if we say smooth union, it is like a Boolean operation. But you see that we have also a blending, a smooth blending between the emitter. That's really nice, because we can create complex emitter using different shape, or for example, we can mix more blend together with different kind of Boolean operation. We can create something really complex. You see that, for example, we have the subtraction, we have the smooth subtraction, we have the intersection, and then again the smooth version. Then we have the add, and then we have the morph. The morph is the possibility to morph one shape to the other one. So that's another amazing feature. By the way, if you think, for example, to a cloud shape, we have the possibility to mix together more shape to create a more complex cloud structure. Okay, so that's amazing because we can mix both together, then we can mix with another shape blend, and then you have a really powerful way to control how it is behaving. So it's just the beginning, it's simple to use it in this way, and there we have a lot of parameters for the emission, and here we are talking about the physical and the dynamic properties. So thanks for watching, guys, and we'll talk more about Embergen really soon when the next lesson will be released, I think in a few days. So bye bye, and thanks again to be part of this project. Bye.